So in this problem, they're giving us, if you notice, this x plus 3y minus z equals 0. This is the equation of a what?
Plane.
And this next one is an equation of a
plane.
And this is the equation of a plane, but they've thrown in this variable. Okay, so they've got this m value, and they want us to use elementary row operations. So we're going to think back to what we learned in Algebra 2 with matrices and see how we can interpret what's happening here. As m changes, what does that do to our three planes? What scenario do they fit? Are they the same plane? Are they parallel planes? Do they intersect at a point? Do they intersect at a line? What's happening here? So as we get started, you may remember with the elementary row operations, you can multiply a row by something, you can switch rows, and you can combine rows. So what I like to do is, well, I want to get, and then your goal is you want to get a 1 and then zeros, and then a 1 in this term and zeros, and then a 1 here and then zeros. So hopefully you've seen, because our goal is to get something to 1 0 0 0 1 0 0 0 1, and then you get an A and a B and a C value, and then this means your 1x is equal to A, your 1y is equal to B, and your 1z is equal to C. And if you get this scenario where you can get the identity matrix here, do you remember this from Algebra 2?
Yes.
Then this would indicate that these three planes intersect at the point A, B, C. Okay, so that's one scenario that's going to happen. So when we look at this, they threw in these variables, and we'll see some problems where they give you three planes without variables. They ask you to do elementary row operations. You work down, and you get this scenario, and that's the point where those three planes intersect. We'll also talk about what does it look like when you get down and they intersect at a line. Okay, so with this, the first thing I would do would be, I'm going to keep this top line, and then I'm going to multiply the top row. I'm going to say -3 times row 1 and add it to row 2, and that becomes my new row 2. So -3 plus 3 is 0. -3 times -3 is -9, plus 5 is -4. This multiplied by -3 is a +3. Minus 1 is a 2. This 0 and 0 makes my life grand. It's a 0. Then I'm going to say, well, let's see. Let's say row 1 minus row 2. I've got a couple options as to how I can get rid of that 0. But if I say this minus this is 0. This minus this, that's a +8. This minus that, now I have a -3 and a positive m. Okay, and then this minus this changes the signs. Now I have an m squared minus 9. Okay, so I've achieved my zeros here. Now I need to get this to be a 1, and then get zeros. So if I make that a 1, I can divide by -4. So this is -1/4 of row 2, and I'm going to keep everything else the same. So that's that. That becomes a -1/2, and that becomes 0. So now I've gotten that 1. Okay, and now I need to get these to be zeros. And so since this is already a 0, it's not going to have any impact up here, which is what I need. So I'm going to keep this row the same. And then I'm going to multiply, I'm going to say 3 row 2. Oh dear. I'm going to say -3 row 2 plus row 1. Goodbye. Enjoy lunch. Y'all can keep working on this on Monday. Sorry. Okay, I'm so sorry. Hang on just a second. So this multiplied by 3, that's still 1. In my chair. That multiplied by -3 is a +3/2 minus 1. Goodbye. This is just so fun.
I'll meet you there.
I can't think. Hang on. This is.
I'll meet you in like 5 minutes. I'll be at the.
We'll be quick. We'll be quick. Goodbye. Thank you. -3. That's a 3/2 minus 1. Goodbye. It's a +1/2. That's still 0, which is great. Goodbye. Y'all be good. You know, you laugh or cry. Okay, so here we go. And then on this one, if I take this row here, multiply it by -8 and add it to that one. So if I say -8 times row 2 plus row 3, that will clear out this 8. So that's 0 plus 0 is still 0. -8 plus 8 is 0. -8, that makes us a positive 4.
Yeah.
Plus, -3, that's a 1 plus m. Do y'all agree? Okay. Check my math because I'm a little distracted. This is, I love it. I love it. 0 times -8 is still 0 plus this. Okay, so we're still sitting here. Okay, and so it would be nice. Well, so what we have is if this, hang on just a second. Yes, okay. If we come down here and I have this 1 plus m, and so that's kind of what I'm looking at for just a second. Oh, sorry. Yeah, go stop that. There's just chaos everywhere. God, I love school. Okay, if this were equal to 0, then we would end up with a situation where 0 equals something. Okay, which if 0 equals something, that's a false statement, which we'll talk about in a second. So if m is equal to -1, we say that this the system is inconsistent. So plug in -1, and we would find this matrix 0, 0, 0, and then -1, that's a positive 1, that becomes a -8. This is a false statement, which that means that there is no common point of intersection. Now, if m is a different value, then we can come up with, hang on, I'm a little shaky on this. Then we can find a different point. So let me glance at, let's look at the book for just a second. Oh, I wasn't showing the right page. Once again, terrible production. Okay, so what we're looking at here is if the normal vectors are all different, so there's nothing parallel here. And so if m is not equal to -1, then there is a unique situation, a unique solution. Okay, as long as it's not -1, then I could solve for z and get that this z value is something. Then I could go back in to my previous matrix and plug this back in, and I'd know that my z is -1, but I would plug in -1 times what I just got for z. And so when you clean this mess up, you come down to those 3, and then you do the same thing for x, plugging in y and z. Here's the y that you found, there's the z value. Plug it in, and you get this mess of a situation, provided that m is not equal to -1. And I'm going to let you go eat lunch, and we'll go from there.